First of all, I know it looks like I have a black eye. I got this at my jujitsu class. It looks a lot worse than it feels like. I don't even remember getting the black eye, and it doesn't really hurt that much. So try to ignore it. I still want to put out a video despite the look. So last summer, I broke my collarbone at a skate park. I had to get surgery and everything. One of the negative parts about it was that I missed a whole week of PTO, paid time off, that I had already scheduled right after I broke my collarbone. So I took advantage of that time and rested, took care of myself. So I was really looking forward to my time off in January. But leading up to that week, I had a sore throat. I ended up getting sick. So in the last year, both of my 2 weeks that I've taken off, I have not been healthy. It's a bit frustrating, and I decided that I don't ever want to get a cold again, especially on my paid time off. So I'm going to learn everything I can that'll help me prevent getting a cold in the future. I'm not the only one who's losing by catching a cold. The US loses $40 billion a year from people missing work. And it's the number one cause of people missing work and children missing school as well. The cold is actually an upper respiratory tract viral infection. It's an infection of the nose, the sinus, the pharynx, and the larynx. The symptoms peak around 1 to 3 days, and the symptoms can last 7 to 10 days and can last up to 2 weeks. For me, typically, my cold will last 2 weeks, give or take. This last time it was a little under 2 weeks. The common cold symptoms can include sore throat. That's my first indicator. Rhinitis, which is an allergic reaction to an allergen releasing histamines that cause watery eyes and that sort of thing. Runny nose, cough, and nausea or malaise. In general, flu symptoms can be worse and can have serious complications. COVID-19 has even worse complications, as you may be aware. But here I'm just talking about the common cold. Rhinoviruses are actually the most common, but there are hundreds of strains at a given time that cause a common cold. The rhinovirus accounts for 50 to 76% of colds. And this is of the identified pathogens. There are also unidentified pathogens that cause a cold as well. Adults average between 2 and 3 colds a year. I would say I have about this many, and I'm trying to improve on that. Children can have up to 6 a year, and the elderly have about 1 a year. So it's more common in younger individuals. An increased understanding in the rhinovirus may help us develop vaccines and create better antivirals. The rhinovirus is a spherical virus, and it's made of positive sense RNA that gets translated in the host. So RNA is an intermediate between DNA and protein. It carries the genetic message that will be translated into the amino acids of a protein, where the entire genome is RNA and it gets translated directly, which means that the ribosome, which makes protein in the host, will create this really long chain of amino acids. And there are sections of that polypeptide that are proteases, which cleave the protein in certain positions. And so those parts will cleave, presumably, other rhinovirus polyproteins into their individual proteins. And those individual proteins will make up the viral coat to make spherical peptide, the other proteins that aid in the survival of the virus. Not that a virus is a living thing, but it has evolved to perpetuate itself in other living things. The viral coat protein is actually what is detected by the host. It's detected by surface receptors and allows for endocytosis, which means that the cell basically just engulfs the virus. And then it creates something called an endosome, which is basically a bubble or a vesicle or a cell within a cell. And the coat of the protein falls off in this endosome because it has a low pH. Presumably, the ribosome is able to access the RNA somehow and translate that mRNA genome into protein. The CDC recommends for you to wash your hands, avoid sick people, and don't touch your face. I have this bad habit of stroking my beard, very contemplative, but you don't want to bring any germs from your hands into your mouth, your nose, your eyes. And this can easily happen when you're at a public place or if you're at work. You touch a doorknob and then bring your hand to your face out of habit. This is a very easy way to get sick. And you want to be listening to any indication that someone might be sick, like a cough, a sneeze. You want to avoid people who are sick because not everyone's going to tell you that they're not feeling well. They may think that they're not contagious when they really are. It takes a certain amount of time, proximity, to catch a cold if you're going to catch it through the air. So make sure in general to keep your distance from others and not spend too much time close to others that potentially might be sick. People more frequently get colds in spring and the winter, so it makes sense to be more vigilant during those months. Once you are sick, it's important to take plenty of rest and drink plenty of fluids. Over-the-counter meds do not make a cold go away faster in terms of viral load, but it has been shown that vitamin C and antihistamines can improve the symptoms of a cold. Since there are so many types of viruses that cause the common cold, it's possible to catch one while you're still recovering from another. Unlike COVID-19 that generally has one dominant strain at a time, you can catch any of the 100 strains of viruses that cause the common cold even while you still have one. Why don't we have a vaccine for the common cold? The common cold viruses are so variable in their protein coat structure that is recognized by our immune system. It's hard for our bodies to find a commonality between these cold viruses so that we can recognize all of them. And there's also a fast mutation among cold viruses that helps the virus evade our immune system by constantly changing so it can't be recognized. Many pharma companies are targeting flu and COVID-19, which have more serious complications. But there have been efforts to create vaccines that target groups of viruses that cause the common cold. The vaccines are often viral coat proteins, inactivated viruses, or mRNA that produces coat protein. And what happens is, in these different ways, the exterior of the virus is presented to the host or to the patient, and the patient's body learns to recognize that exterior of the virus and learns how to neutralize it or inactivate a virus when it actually becomes present. There have been strategies to combine viral coat proteins so the body can learn how to target all the different types of viruses that cause the common cold. But often when this is done, it reduces the efficacy because the amount of coat protein introduced has to be less because there are so many types that need to be used. So far, the vaccines haven't been designed to be broad enough to recognize a broad spectrum of viruses, or we haven't been able to combine so many vaccines because of the reduced efficacy that happens when you combine vaccines. I'm so tired of getting sick so frequently. My goal is to not have a common cold for 5 years. I will be super vigilant. Thanks for joining me at the Journal Club. Don't worry, I didn't get in a real bar fight. I got this in jiu-jitsu. Thanks for joining me. See you next time.